Have you ever wondered how Netflix recommends movies that you actually enjoy watching? Or how YouTube always seems to suggest videos you are interested in? It almost feels like these applications can read your minds. But they can't. They learn from data. In today's video, we are going to understand how computers learn from data, what machine learning is, and how we will even build our very first machine learning model using Python. So let's get started. Let's imagine you are working as a machine learning engineer at Netflix. Netflix already has information about thousands or even millions of users. To keep things simple, we will use a small dataset. Here we have previous users. For each user, we know three things: age, gender, movie type they liked. Now suppose a new user joins Netflix. He is 17 years old, male. Which movie would you recommend him? Take a few seconds and think about your answer. Most of you probably answered action movie, right? But here is the interesting question. How did you know that? Did you randomly guess? No, you looked at previous examples, then you observed patterns. Finally, you made a prediction. Let's see those patterns. Boys up to age 12 mostly like cartoons. Teenage boys prefer action movies. Younger girls like fairy tales. Older girls mostly watch dramas. Using these patterns, we predicted that a 17 years old male would most likely enjoy an action movie. Notice something interesting. Nobody gave you a formula. You simply learned from examples. Now think about yourself. Whenever you learn something new, you usually follow three steps. First, you observe examples, then your brain discovers patterns. Finally, when a new situation appears, you use those patterns to make a decision. Surprisingly, computers can do exactly the same thing. We provide previous examples, the computer studies those examples, it learns the hidden relationships, then it predicts the answer for completely new data. This process is called machine learning. So, machine learning is simply teaching computers to learn from experience instead of programming every rule manually. Now, let's place machine learning in the bigger picture. Artificial intelligence is a very broad field. One of its most important branches is machine learning. Machine learning itself has several branches. Today, we will focus entirely on supervised learning because it is the most widely used approach in real world applications. Why it is called supervised learning? Because every example already contains the correct answer. Look at our dataset. Age and gender are called input features. These are the pieces of information we give to the model. Movie type is called the target or label. It is the correct answer. Since every training example already has the answer, we call this labeled data. This is exactly what makes learning supervised. Now, another important term is training data. Think of yourself as a student. Before an exam, what do you study? Your books, your notes, your lectures. Those materials help you learn. Similarly, a machine learning model learns from training data. It studies thousands of examples. It discovers relationships between inputs and outputs. Once it finishes learning, we say the model has been trained. So far, we have understood the theory. Now, let's actually teach a computer using Python. We will use this exact movie dataset. We will train a machine learning model. Then we will ask it to recommend a movie for our new user. Now it's time to write our very first machine learning program. Before we can work with data, we need the Pandas library. Pandas helps us read, manipulate, and analyze datasets. We import it using the alias PD, which is the standard convention used by almost every Python developer. Now let's load our dataset. This dataset contains previous Netflix users. This is the simulated dataset, not the actual users of the Netflix. Let's display the very first few rows of the dataset. For each user, we have the age, gender, and the movie type they preferred. This historical information is what the machine learning model will learn from. Always inspect your dataset before training a model. This will help us verify that the dataset has been loaded correctly and that the columns are what we expect. The info function gives us the summary of the dataset. It tells us the number of rows, the number of columns, the data types, and whether any values are missing. Checking this is an important habit before building any machine learning model. Now we separate our dataset into two parts. X contain the input features. In our example, the features are age and gender. These are the pieces of information that the machine learning model will use to learn. The second part is Y. This is our target, also called the label. Here, the target is the movie type. So the model will learn the relationship between age, gender and movie type. Now let's check the shape of our data. The shape tells us how many training examples we have. Notice that X has two columns because we have two features, while Y contains one value for each training example, the correct movie type. Now let's import our first machine learning algorithm. We will use a decision tree classifier. A decision tree learns by asking a sequence of questions. For example, is the user younger than 12? Is the user male or female? Based on these questions, it reaches a prediction. Now we are creating an object of decision tree model. At this time, the model knows nothing. It has not learned any pattern yet. Think of it as a new student entering a classroom. This is the most important line in machine learning. The fit function starts the learning process. We provide the input features X and the correct answers Y. The model studies these examples and learns the hidden relationship between the inputs and outputs. After this line executes, our model is trained. Let's create a completely new user. This person was never part of the training data. The user is 17 years old and male. Now let's see what our trained model predicts. We use the predict function whenever we want the model to make predictions on new data. The model uses everything it learned during training to predict the most suitable movie type. Let's display the prediction. Great! Our model predicted action. This is exactly what we expected based on the patterns we observed earlier. Congratulations! You have just built your very first machine learning model. But here is an important question. How do we know whether our model is actually good? Right now, we trained the model using the entire dataset. In real world machine learning, that's not enough. We need a separate dataset to evaluate the model. To evaluate our model properly, we divide the data in two parts: training data, testing data. To divide our data into two parts, we can use the train test split function of the scikit-learn library. The training data is used for the learning. The testing data is kept completely separate. The model never sees these examples during training. This is similar to students studying from books and then taking an exam using new questions. Here, test size is 0.2, means we are reserving 20% of the data for testing. The remaining 80% will be used for training. We will create a fresh model. This ensures we are starting from scratch and learning only from the training data. This time the model learns only from the training data. It has never seen the testing data. Now let's ask the model to predict the movie type for the unseen test data. This is just like giving exam questions to a student. Now we will measure how well our model performed. For that we will import accuracy score from the sklearn.metrics library. The accuracy score compares the model's predictions with the actual correct answers. A higher accuracy means the model learned the patterns more effectively. This is our model's accuracy. It tells us what percentage of predictions were correct. Earlier we saw the decision tree learns by asking a series of questions. Now let's actually visualize those questions. To do that, we import plot tree from scikit-learn. We also import matplotlib, which is a Python's most popular visualization library. Before drawing the tree, let's create a figure. The figure size parameter controls the width and height of the image. Since the decision trees can become large, we are using a bigger figure so everything is easy to read. The first parameter is model. This tells Python which trained decision tree we want to visualize. Remember, this model has already learned from our training data. These are the possible predicted classes in our dataset. These classes are the movie categories like action, cartoon, drama, and fairy tale. Next, we provide the names of input features. This allows the decision tree to display meaningful questions such as is age less than or equals to 12? We are giving feature names as age and gender. The filled option adds colors to the nodes. Each color represents the predicted class. It also makes the tree much easier to understand visually. Finally, rounded equals to true simply makes the boxes rounded instead of rectangular. It doesn't change the model, it only improves the appearance of the tree. Finally, show function will display the decision tree. Now, if we look at the very first node, that is root, it applies some condition that whether the age is less than 12.5. If that's true, then it checks the gender, whether the gender is male or female. Based on that, it recommends the class. For an example, if the age is less than 12 and the gender is female, it recommends the movie that is fairy tale, and that is the correct answer. So far, we have trained our machine learning model. The model has learned patterns from our training data. But here is an important question. Do we have to train the model every time we want to make a prediction? Imagine Netflix, YouTube, or Amazon, millions of users request recommendations every second. It would be extremely inefficient to retrain the model for every new user. Instead, we train the model once, save it to disk, and later simply load it whenever we need it. This makes the prediction process much faster. To save our trained model, we will use Python library called Joblib. Joblib allows us to store Python objects, including trained machine learning models, into a file. Later, we can load the same model without training it again. The dump function saves our trained model into a file. The first parameter is the model we want to save. The second parameter is the file name. Here we are saving it as movierecommender.pkl. The .pkl extension stands for the pickle, which is a common Python format used to serialize objects. Think of it as taking a snapshot of the trained model and storing it on your computer. Everything the model has learned is now safely saved in the file. This is exactly what happens in real-world applications. Engineers train a model, save it, and deploy the saved model to a server. When user visits Netflix or YouTube, the application loads the trained model and immediately starts making predictions. Now let's imagine we have closed Python and come back tomorrow. Instead of training the model again, we simply load the saved model from the file. The load function reads the model from disk. Notice that we don't call fit again. The model already remember everything it learned during training. Let's create another new user. This user is 29 years old and female. Remember, this user was never part of the training dataset. Now let's see what our saved model predicts. Even though we loaded the model from a file, we use it exactly the same way. We simply call the predict function and provide the new user's information. The model uses the knowledge it learned earlier to make a prediction. Our loaded model predicts drama. This confirms that the model retained everything it learned before it was saved. We didn't retrain it, we simply loaded it and started using it immediately. Congratulations! Today you have completed the complete machine learning workflow. We have learned how to read a dataset, separate features and labels, train a machine learning model, make predictions, split data into training and testing sets, evaluate the model using accuracy, visualize the decision tree, save the trained model, load it later and use it for a new prediction. This is the same workflow you will follow in many real-world machine learning projects. In the next video, we will explore another machine learning algorithm and compare how different models learn from the same data.